Hi everyone, myself Benny John, Assistant Professor. Today we are going to see about Theory of Machines, Unit 5, Balancing and Vibration. In this chapter we are discussing about the forced vibration. The forced vibration. When the body vibrates under the influence of external force, then the body is said to be under forced vibration. Example, a ring of electrical bell, vibration of air compressor. Next one is types of external excitation, that is of forced vibration. These three types: periodic force, impulsive types, random forces. Next, harmonic disturbance, that are otherwise it is known as spring mass system. The amplitude of the forced vibration is given by x equal to f0 by square root of s minus m omega square into plus c omega the whole square into sin omega t minus phi. So whether f0 is denoted as excited force and phi is denoted as phase lag. As other notes, the maximum amplitude of force vibration is given by m x max equal to f0 by s the square root of 1 minus r square the whole square plus 2 summation r whole square. The r frequency ratio equal to omega by omega n. The omega is the angular velocity of excited force is applied. The amplitude of the force vibration is given by x equal to f0 by the square root of x minus m omega square the whole square plus c omega the whole square into sin omega t into phi. The maximum force given by phase lag, that's a y equal to tan inverse into 2 epsilon r by 1 minus r square, where r is equal to frequency ratio. Whether the displacement takes place after making the force displacement vectors, the force vectors by the some angle phi is known as phase lag. The magnification factor, it is the ratio of maximum displacement of forced vibration to static deflection x0 due to the static force denoted by mx. The mf equal to x max by x0 equal to 1 by the root of 1 minus r square the whole square plus 2 summation r the whole square. Next, it is clear that the same formula is not here, that magnification factor is depends upon ratio of critical frequency and damping factor. That is the harmonic disturbance, which is shown as the graphical curve. First one is frequency response curve. It is drawn for between the magnification factor and frequency ratio is known as frequency response curve. In this figure, we can show that graphical method. The x-axis the frequency and y-axis amplitude. Whether the amplitude increase, the frequency also increase. Whether the amplitude decrease, then the frequency also decrease with the delta ratio. Next one is the phase frequency response curve. It is drawn between the phase angle and frequency ratio is known as frequency ratio. This is known from the figure. We can give the graphical representation. The x-axis the frequency and y-axis phase angle. Whether the phase angle increases but the frequency will decreases. It shows that the graphs of delta 0.4, 0.3, 0.5, 0.6, 0.7. That's all. Next one is transmissibility. It is a measure of effectiveness vibration. Isolating material is known as transmissibility. That's the types, two types: force transmissibility and motion transmissibility. Next one is force transmissibility. This defined as the ratio of force transmitted to the force applied of the system. It is also known as isolating factor, It is denoted as epsilon. Next, the first transitive formula is equal to force transmitted to the foundation by force applied on the system. Epsilon equal to Ft by F0. Therefore, square root of 1 by 2 Cr the whole square by the square root of 1 minus r square the whole square plus 2 epsilon r the whole square. The phase log the phi omega equal to minus alpha equal to tan inverse 2 Er by 1 by r square minus tan inverse into 2 Er. Next one is motion transmissibility. It is defined as the ratio of absolute amplitude of the mass to the base excitation amplitude. It is also known as amplitude transmissibility. It is denoted as EA by equal to x max by y, where the square root of 1 by 2 Cr the whole square by the root of 1 minus r square the whole square plus 2er the whole square. That's all. Thank you.